Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at how to find the area under a curve using a definite integral. Before I start with area under a curve, I just want to talk about area under a straight line. If we had a line such as this one, y equals 4x plus 2, and you were asked to find the area under that line between the x values of 1 and 3, that means finding the area under that line and above the x-axis. We could do it because the shape that's formed is a trapezoid. Trapezoid means two sides are parallel and the other two are not. Now, in order to find the area of a trapezoid, if I call this side M and this N, and then this distance between H, the area will be H times the average of M and N. So in our example here, I need to know this length. To find this length, it would be the y value. So when I put a 1 in for x, 4 plus 2 is 6. I would need to know this y value. I would put the 3 in for x and get 14. And then this distance between the two parallel sides is 2. So my area would be equal to 2 times the average of 6 and 14, which is 10. So my area would be 20 square units. So we would know how to find the area under a straight line, but what if we want to find the area under a curve? For example, what if I wanted to find the area under the curve y equals x squared plus 2 between the x values of 1 and 3? I can't use geometry to do this. Fortunately, we can use calculus. The area under a curve can be obtained by taking the definite integral. It was found that the area under a curve that reaches from a to b, so those are the x values, is given by this formula. So in other words, we can use the definite integral to find the area under a curve. Let's try this formula with this particular example. If I want to find the area under this curve, then I find the integral of this function. And I want from the x value of 1 to the x value of 3. So the value on the left has to be your lower limit. The value on the right has to be your upper limit. You're moving left to right. When we find the integral, we'll get 1/3 x cubed plus 2x. I'm showing that I'm going to be evaluating that at those two values and subtracting. To evaluate this, I put 3 into this function. Then I subtract the value of this function when x is 1. And when I do the calculation, I get an area of 38/3 square units. Let's do the example that I started with the area under the straight line, and that's evaluated or calculated using this. So according to this formula, the area under this straight line from 1 to 3 will be the integral from 1 to 3 of the function 4x plus 2 dx. When we integrate that, we'll get 2x squared plus 2x. Then I evaluate it when x is 3. I evaluate it when x is 1. And then I subtract. So I'll get 18 plus 6 minus 4 is 20 square units. So you can see that this does indeed work because we were able to do this geometrically as well as with our definite integral. And we got the same result. Let's take a look at some more examples. In this example, it asks us to find the area under the curve of y equals x cubed plus 4 between x equals 0 and x equals 2. It's not necessary to draw a graph. I did in this example just so you could see the shape that we're working with. But in order to find that area, you just set up your integral. Our f of x is our y function, so it's x cubed plus 4 dx. And our lower limit is 0, our upper limit is 2. Always going left to right. The lower limit should be the smaller value of x, and the upper limit should be the larger value. Now we integrate. So that first term will be 1/4 x to the 4th plus 4x. And now we evaluate. We evaluate this integral when x is 2 and when x is 0. And when we do the calculation, we get an area of 12 square units. Let's do one more example, and this time we'll do a power function. Our next example asks us to find the area under the curve of y equals the square root of 4x plus 1 between the x values of 0 and 2. I have the graph drawn and the area shaded, but that's not going to be necessary. Just understand that in order for you to find the area, you set up your definite integral. So the area will be the integral from 0 to 2. Always use your lowest value of x first for the lower limit, and then the greater value of x for your upper limit. F of x is square root of 4x plus 1, which I'll write as 4x plus 1 to the 1/2 dx. This is a power function, and in order to integrate that, we need our du factor. So this is u to the n, where the du factor is going to be 4 dx. So I need a 4. But I can't simply multiply by 4, that's changing the value. I multiply by 4, I also need to multiply by 1/4, which I will do outside of the integral sign. Now that I have my du factor exact, I basically ignore it, and I plug into my power rule. So the integral will be 1/4, 4x plus 1 to the power of 1/2 plus 1, which is 3/2, divide by 3/2, and I'm indicating that it's a definite integral. When I clean that up, I'm going to have 1/4 divided by 3/2, which is 1/4 times 2/3, which reduces to 1/6. When I evaluate this, I'm going to leave the 1/6 outside, and I'm going to put a 2 in for x. 4 times 2 plus 1 is 9, so 9 to the 3/2. Minus, when I put a 0 in, that gives me a 1 to the 3/2. Square root of 9 is 3. 3 cubed is 27. 1 to the 3/2 is 1. So that will be 26 over 6, or 13 over 3 square units. So in order to find the area under a curve, or in other words, the area between the curve and the x-axis, you simply do the definite integral. I hope you'll have an opportunity to do lots of practice with these questions. And when you're ready, you can move on to the next video, which is numerical integration. So we're going to look at the trapezoidal rule as well as Simpson's rule. But until then, take care.